In the next part of our paper pointer exercise, I would like to finally fix this rather strange value of q, to say that it equals a, and this way I know that a is the name of an array, and name of an array contains the address of the first element. So this expression a, which is the name of the array, returns the address of the first element in this array. So of course the address of the first element of our array is AC, and therefore the address that we're manipulating here, of course, is AC, hexadecimal. Of course, it's an address of an integer, and this is a complete statement. And here, of course, let's change the value of q, that now it's pointing to this location in memory. So now q should be pointing to this integer in memory. And therefore, the address stored by pointer q changes to hexadecimal AC, which in our fragment is the address of this integer. Let's try again to increment pointer q. This time, if we try to increment pointer q, it will again account for the size of the element that it's pointing to, which is an integer, and it will change its value from AC to B0. So as a result of it, it will become B0, because if it was pointing to this integer, now it will be pointing to the next integer, which simply is located right here in our memory diagram. Of course, this type of incrementing a pointer is completely legal and well intended. So once again, the numeric value of this statement would be B0, because this is now the new value, and we are manipulating addresses of integers, and this is also a complete statement as in terms of the language construct. In our next example, let's try using pointer. So again, this is a complete statement, and we're dereferencing pointer q. Pointer q contains address B0. This is an address of an integer, which happens to be the second element of our array, and it contains value 2. So of course, dereferencing pointer turns it into this value, and this becomes value 2, which is now assigned to integer x. The data type, of course, is just a plain int, and this is our statement number 22. Also, of course, we can try to decrement integers, and this decrement statement would just decrement the value in this location. This is location of variable x, plain vanilla. Decrement, of course, x becomes 1, and the value that we're manipulating is an integer value, and this is not a complete statement, it's only an expression. I just want you to kind of distinguish between complete statements and expressions, because there is a difference. Expressions could be used as sub-expressions of larger expressions, which eventually will form complete statements, and there is a difference. So it's important to recognize, but at the same time, just be sure to realize that every expression that you use in C and C++ has the type. So this is why when we're making our progress through these examples, I always try to give you the data type of language construct that we're trying to use in every particular case.